My name is Rob, and I'm building a hypercar, and today we're finishing the construction of the mill. As you can see on the table, there's a lot of parts ready to install. We're starting by connecting the ball screws on the x-axis and the motors for that. So let's get going. So as you can see, one of the stepper assemblies for the x-axis is already connected and put together, just so I could check that it all worked. I even put the plug for the controller already on it. The other side of the x-axis is not put together yet. So motor mount for the x-axis, as you can see, all the supports are still on it. It just came from the 3D printer like this. We're going to clean that up, drill out the holes, and mount this on the right side of the x-axis. This is the motor mount. You can probably make out right here that the motor fits right in there. Obviously, it has to be cleaned up a little bit. So let's get to that. Well, that's a pretty good fit for a 3D printed part. I don't think it will hang. You know, that's about a 2.5 kilo, a 5-pound motor. That's hanging just by friction on the 3D print. Pretty happy with that, but let's bolt it down anyway. But of course, first, the flexible coupler. It's got the rubbers in there, so it has a little bit of give. And while we got the camera this close, maybe it's nice to see. Look, so these are 2 aluminum parts that fork into each other with some rubbers in between. And so there's a little bit of play with a lot of pressure on it. So that means when the motor turns, it has a little bit of time for the shaft to turn, but it will turn. So just to make sure that you don't get too much pressure on the motor. So you may notice that I'm putting this all together just with nuts and bolts with washers. Not putting any thread locker or anything like that on there. I will probably do that once I'm sure that the machine works the way I want it to. But for now, let's try it out so it's still able to disassemble. And then when we're happy with it, we'll put some thread locker on. Well, all assembled. Let's see if it fits. I'm saying that fits pretty well. So let's drill some holes and mount this solidly. Well, that should be the mounting for the final time. So slide it on. Now, you know what? We'll tighten it down after we've put the bolts in. And obviously I'm using big washers here to distribute the load of the bolt head. Plus I made the holes in the 3D print slightly oversized, so it's got a little bit of give. I want the motor to move in line with the shaft as much as possible. You can see the holes are way too big, so the thing can slide up and down, left and right, just a little bit, give the motor the ability to align with the screw. I'm tightening everything by hand. You're probably asking, well, does the guy have an impact driver or something, an electric driver to do this faster? Yes, I do, but I want to feel how it goes in. I just put the tabs in, it's in a 3D print, I don't want to over torque it, so I'd rather do it by hand. I spend a little bit more time than crush my 3D print or break a bolt or do anything that is hard to fix. Because the time savings of doing it faster, you lose that really quickly when you have to take a broken bolt out. And then for the internet standard, right? That's not going anywhere. This motor assembly, and it's actually fairly heavy, goes on this side right here. Obviously it aligns with the shaft through the flexible coupler, and then the 3D printed part connects to the table with a long straight piece so it can handle as much torque as possible. So now the ball screw is connected to the motor, but the carriage is still moving by itself. So next thing we're doing is connecting the X ball screw to the carriage. And to do that, I'm mounting a Cross 2020 and attaching that with another 3D printed part to the ball screw nut. Now, there's an important aspect here. Just like the coupler to the motor has a little bit of play, this has play enough that it can move a little bit. If there's enough pressure on that, this will slide over this bar. So if the carriage ever gets jammed, the motor will slide this across the bar. In normal operation, that shouldn't happen, but if a jam occurs, it will slide. And this will help make sure that it doesn't completely twist up the machine or burn out the motor. In up the 3D print, there's a couple of supports in the bolt holes. So putting a 2020 lock nut, jam nut in, and short screw. Hard to film, but it's on. I think you can probably see that in there. So now, let's see if we can make this work. If we slide the profile in, now the jam nut is in the channel, and it still slide, but when we tighten this screw, it will tighten up, and if enough torque comes on the carriage, it will actually slide over the shaft. So taking that back apart, because that's for later. For now, we're attaching this to the screw. So next step, obviously this is going to slide through the block and connect here with the jam nuts. So I need to drill 2 holes in either side of this. The 3D printed block is on, the holes are in. So let's put all the hardware on and assemble. Okay, there we go. And then of course the most important one, locking it all down. So mounted, solid. So now when the motor turns, the ball screw will turn, taking the nut with it. And when the carriage gets blocked for any reason, this will slide, giving it about 40 centimeters, about 16 inches of movement. And that should be enough to press either the stop button or for the system to recognize, hey, this motor is working too hard, and shut itself down. Other side, same process. I already cleaned up the 3D print, so that's ready to go. Don't need those bolts yet. So let's drill some holes. These nuts are just slightly too small for my fingers. I tend to drop them all the time. Okay, there we go. Same assembly. So now that the x-axis is together, let's work on the y and the z-axis. And while I was preparing for that this week and making parts, I figured out that there are nice blue and yellow parts that are here and here can actually be combined to include several functions together. I'm already prepared for that, but I figured it was easier to make a single 3D printed part instead of bolting 3 pieces together. So we're going to be taking apart everything on the side and remounting it so we can have all functionality together. And I put this part together partially already because I tried it to make sure it actually works. So let's mount this. So the mount plates are in. There's two 2020 extrusions that hold it together. They're actually used to mount the Y-axis motor and the Z-axis pillow block. The bottom one doesn't need much help. It's just there for construction. The top one needs a lot of separate parts on it. So for now, we'll just install the bottom one and then go to the other side, do the same thing there, and then come back here to finish the construction. I said there's not much that needs to go on this bottom one, but I do know that in a later video we're going to need these two mounts, so we're going to slide those on already, just so I'm ready to install something in the future. So now that that panel is off, we're ready to put the next one on. Let me drill out some of those holes and clean up the 3D print artifacts, and then we'll get to installing it. I'm not a big fan of threaded inserts, but they have their place, and this is one of those times where it makes sense to use threaded inserts. So we melt those in and provide a good place to anchor the bolts. So that's all the side blocks for the Z and the Y axis connected. Next, we're going to put the cross braces on with all the connections for the Z axis. It's another 3D print that I have to clean up, so that's next. And then we'll start putting everything together. And because the Z and the Y axis are a very integrated system, it will actually go on really quick. So I won't be talking a lot in between, but after we're done, I'll explain what we've done and how everything clicks together. This very elaborate 3D printed part is what we use to mount the Z motor, the Z ball screw, and attach it to the frame of the rest of the machine. It's a pretty complex part, and as you can see, the motor clicks in and is then secured with 4 bolts and centered because the hole in the middle is just the right size for this stepper motor. Then the ball screw mounts on top of the motor. As you can see, it's a tight fit, and it should be because it's a friction fit. Tighten the screw. This is the part that connects to the ball screw and then connects to the gantry, the carriage. And as you can see, the bolts here are an interference fit. The bolt head is actually in the space of where the 2020 extrusion is going to be. Next, we're mounting the top pillow block, and then the whole contraption goes in and connects everything together. Then we slide in the crossbars for the gantry. It's a tight fit, but that's supposed to be because it's mostly friction fit with some locking nuts inside the 2020 extrusion to make it tight. Now this is again that elaborate printed part where you can see we have channels for the 2020 extrusion that go through. Again, a tight fit, but that's what it's supposed to be. Those 2020 extrusions again are tightened with lock nuts, so they're
not sliding anywhere, and then connect it to the uprights using, again, lock nuts with some M5 bolts. A very sturdy and flexible construction that can easily change in size. So if your setup is slightly taller or smaller, or you decide to use different profiles, it can easily accommodate that. And as you can see in my face, it was a little tight. It was a little hard getting those things in there. And then, of course, finally doing the other side, same process, same parts, just on the other side. On this shot, I especially like the sawdust that comes out like smoke every time I tap it. Then we mount the Y ball screw and the Y motor. Don't have a lot of video of this, we had some camera problems. You can see the Y motor is mounted on the same 2020 extrusions that mounts the carriage and the Z ball screw. So all of it becomes one unit. For the sharp-eyed viewer here, I used some washers. I didn't have the right length bolts, so I filled it up with washers, and that's fine, plenty sturdy. It's now all together, so the Z is supporting itself, so keeps it up. Well, proud man there.
So that finishes the whole construction with the motors and the ball screws. Next step is going to be the wiring, lots of wiring, end stops, and then build the carriage in the middle for hanging the spindle off of. In the episode after that, we'll work on the electronics, which, if you look behind me, it's all sitting ready on the table to work on next. Thank you for watching. Subscribe, like, comment, let me know what you think of the build, tell your friends about us, and we'll see you next video.